Good day, everyone. Welcome to another session in our Civil Engineering online review here in Visavilla Review Center. So for today, we will continue with our remaining topics in solid geometry, the solid figures that we have not discussed, and then after that, we will go to the next subject, which is the spherical trigonometry. Okay, so sphere is a solid figure bounded by revolving a semicircle about its diameter. So as you notice now, if you have a semicircle and then you revolve the semicircle about a diameter, then by a full revolution, we can form a solid which is called a sphere. So the center of the sphere is denoted by letter C or O, and the radius is denoted by R. So the surface of a sphere is the set of all points from its center. So we have here a figure of a sphere. So we have here the center denoted by C, and any point on the surface, the distance of any point from the center is called the radius of the sphere. Okay, so we have the surface, no? And then the interior of the sphere. And then the volume, formula for the volume of the sphere, we have 4/3 pi r cubed. In the surface area, we have 4 pi r squared. Okay, so we have representative problem. Problem number 1. Three spheres made of lead having a radius of r, 2r, and 4r respectively are melted to form a new sphere of radius r. The ratio of the volume to the surface area of the new sphere is equal to 4.18. Compute the radius r. Okay, so we have three smaller spheres of radius r, 2r, and 4r, and then melted to form a new big sphere with radius big letter r. So if you consider the big sphere, the ratio of the surface area to the volume to the surface area of the big sphere is equal to 4.18. Then you are asked to solve for the small radius r. Okay, so for our solution, simply, the volume of the three spheres is obtained by adding the volume of each. So we have 4/3 pi. For the first, we have r cubed. For the second, we have 2r quantity cube. And for the third, we have 4r quantity cube. So if you compute, this is 305.78 r cubed. So in terms of the small letter or small radius r. Then we can consider the volume of the big sphere. So the volume of the big sphere is 4/3 pi r cubed. So the volume of the three spheres is also equal to the volume of the big sphere because the big sphere is made up of the three smaller spheres that we have here. Okay, so equating the two volumes, so 305.78 r cubed equal to 4/3 pi r cubed. Then we can express the radius r of the big sphere in terms of the radius r of the three smaller spheres. So we have now r equal to 4.18 of r. Okay, then we consider the volume to the surface area ratio of the big sphere. So we have here volume over the surface area. So the volume is also 305.78 r cubed. While the surface area, when the radius is r, so 4 pi r squared. But we can express r cubed in terms of r, no? Or express the big R here in terms of small. So volume over surface area is 4.18. So 305.78 r cubed. Then 4 pi, we have 4.18 r and then square. So r cubed and r squared here cancels out. So the only unknown for this equation is only the small radius r. And solving, we obtain 3. Okay, so that is about the volume of the sphere. No? Okay, another problem we have here. Okay, so sometimes a problem that we may encounter in the board exam is a combination of shapes. No? So for problem 2, we have here a sphere of radius 5 cm and a right circular cone of radius 5 cm and a height of 10 cm stand on a plane. How far from the base of the cone must a cutting plane, which is parallel to the base of the cone, pass in order to cut the solids in equal circular sections? Okay, so solution. So we have here a sphere and a right circular cone. Huh? So they stand on the same base, the horizontal plane, and then the question is, how far from the base where they stand must a cutting plane pass in order to cut the two solids in equal circular sections? Okay, so we have here our figure. So this is now the plane, the base, no? Then we have the sphere with radius 5 cm. So the diameter is 10 cm. Then we have here the right circular cone with the radius at the base at 5 cm and a height of 10 cm. Okay. So let us say the plane passed through here. No? So the plane parallel to the base passed through here such that the two solids will be cut into in circular sections of equal radii. No? So we have here R, R. Okay? So let us say the distance we have to solve. So the distance in question is the distance h, no? The distance from the base to the cutting plane. Okay. So if you consider the sphere, this is the radius 5, then this is the radius r of the circle cut by the plane. So this is also 5 and this is h, so this distance is 5 minus h. Okay? Then from the cone, so we have here, this is h, this is 10 minus h, and this is the radius r of the circle made by cutting the plane to the cone. Okay, so from the sphere, we have from this triangle, we can write our equation. R squared is equal to 5 squared minus the quantity 5 minus h squared. Then we can simplify. We have r squared is equal to 10h minus h squared. Then from the cone, we have here 5. Then we have 10. So the radius of the base is 5 and the height is 10. And then at the cutting plane, the radius here is r and then the height is 10 minus h. So by proportion, we can write r over 10 minus h, r over 10 minus h, that is equal to 5 over 10. So 5 over 10 is 1/2, so r is equal to 1/2 times 10 minus h. And then we can square, we have r squared is equal to 1/4 times 10 minus h quantity squared. Okay, so equating the two equations for r squared, so we have 10h minus h squared, this is minus, no? 10h minus h squared from the equation of the sphere, that is equal to 1/4 times 10 minus h quantity squared from the equation obtained from the cone. Okay? So the only unknown from this equation is the h. And h is equal to 2 centimeters. Okay? So that is about the sphere, na? So, we have now the solids cut from a sphere. So, tingnan natin kung ano-ano yung mga solids na yun, ha? Okay, so, we have here, the intersection of a plane with a sphere is a circle. So, let us say, if we pass a plane through a sphere, na? So, in between the sphere and the plane, you have there a registered geometric figure, and that is a circle. Now we have here, if the plane passes through the center of the sphere, the intersection is what we call the great circle. Now the great circle is the biggest circle cut from a sphere. And otherwise, if the intersection is a smaller one, we call it a small circle. Okay. So I will illustrate it here now. So let us say we have a sphere, and then we will cut the sphere by a plane. Now if the plane passes through the center of the sphere, so the circle registered here in between the sphere and the cutting plane is what we call a great circle. Now obviously, the radius of the great circle is also equal to the radius of the sphere, that is r. But how about if, in case, when we cut the sphere, the cutting plane does not pass through the center, like this, na? Okay. So the circle here is smaller than the great circle, and we call it as a small circle. So that is a small circle, na? So the radius of the small circle is smaller than that of the radius of the sphere. Okay. So the first solid cut from a sphere is what we call a spherical wedge. Spherical wedge, and then the surface of that wedge is what we call a spherical loon. Okay. So a spherical wedge is a solid cut from a sphere that is bounded by two semi-great circles. So we have two semi-great circles. The radius of the wedge is equal to the radius of the sphere. And the angle between the surfaces of the semi-circles in the interior of the wedge is called the central angle. Okay, so we have here a sphere, and then if we cut a solid which is bounded by two semi-great circles. So ito yung two semi-great circles, na? So this part here and the part at the back. So we have here two semi-great circles as boundaries of our wedge. Okay. So we have here the radius r and the central angle theta. Okay. So the solid is what we call the wedge, and the surface here, this surface here, is what we call the loon. So the spherical loon. Okay. So what are the formulas that can be applied if in case we have problems involving spherical wedge and spherical loon? Okay, so I will not derive formula, but we can just use now. I will show it first. So the volume is equal to pi r cubed theta over 270 degrees. So that is if our angle theta is in degrees. And then volume is equal to 2/3 pi r cubed theta if theta is in radians. Okay. So we have now the surface area. So the area of the loon is equal to pi r squared theta over 90 degrees. So theta in degrees, theta in radian. I will advise just use the formula for the angle theta in degrees. Okay. So one representative problem I have here. So a spherical loon has an area of 200 square meters and central angle of 120 degrees. Find the volume of the spherical wedge. Okay, so a spherical loon has an area of 200 square meters and a central angle of 120 degrees. Find the volume of the spherical wedge. Okay, so we will start with the area of the loon. So this is pi r squared theta over 90. We are given the area and the central angle 120. So from this, you can solve for the radius of the sphere. So we can come up with r equal to 6.91. Okay. Then we can have solving for the volume, no? Because we are asked for the volume of the spherical wedge. Okay, so volume is equal to pi r cubed theta over 270 degrees. So angle theta is 120, r is equal to 6.91. So we can simply solve for our volume, 460.68. Okay, so that is about spherical loon, spherical wedge. No? So recall, the solid is what we call the spherical wedge. The surface is what we call the spherical loon. The total surface area, of course, is equal to the area of the loon plus twice the area of the semi-great circles as the boundaries. Okay, so we have here a spherical segment and spherical zone. So a spherical segment, we have two cases here. No? So we discuss each. So the first is the spherical segment with one base. So the spherical segment with one base is a part of a sphere bounded by one small circle called the base and the zone of the sphere. Tingnan natin kung ano yung zone. No? So the perpendicular distance from the center of the base to the point on the surface is its altitude. Okay. So we have here a spherical segment. Okay. So notice that the boundaries here, so this is a solid cut from a sphere like this. No? So we exclude this part. So ito lang. So this is composed of a small circle. No? And then this is what we call the zone. So the part in between, so the part in between the circle and the sphere is what we call a zone. So the surface of that. So we call this the zone. Okay. So we have here the radius r of the sphere. Then we have here the perpendicular distance from the center of the base to the point on the surface of the zone is what we call the altitude, and that is h. By the way, if your h is equal to the if h is equal to the radius of the sphere, then we have there a hemisphere. Can you follow? But if h is less than the radius, then we have there a spherical segment with one base. Or it can be h is greater than r also, no? Because this part here, as you notice, itong part is also a spherical segment with one base. Only we can say that this is the smaller segment cut, this is the bigger segment cut. Okay. So this is the solid. Itong solid na to, we call it the segment. And the surface is what we call the zone. So what are the formulas involved? So the volume of the spherical segment with one base is equal to pi h squared over 3 times 3r minus h. Then the area of the zone is equal to 2 pi rh, where r is the radius of the sphere. So take note, r here is the radius of the sphere. Itong given na to. Not the radius of the base. Okay? Hindi natin pinakita ang radius sa base. Only the radius of the sphere. Okay. So we can have representative problem to illustrate. Okay, so problem 1. The surface area of a sphere is 900 pi square centimeters. What is the ratio of the area of the zone of the second segment to that of the first if the altitude of the first segment is 6 centimeters? Okay. So, una, we can solve for the radius of the sphere. So, we are given the sphere, and from the formula for the volume or surface area, recall we are given the surface area. Okay, so that is 4 pi r squared. So that is equal to 900 pi. So r is equal to 15. Tama ba? 900 pi? 900 pi. I thought 900 lang. Okay. So r is equal to 15 centimeters. Okay. So the diameter is equal to 30. So if this is the diameter 30, so stated in the problem, there are two segments on this sphere, no? The first and the second. So meaning, we will slice this into two segments. We have there, no? And then, the altitude of the first segment is 6. So meaning, the altitude of the second segment is 24. Because the diameter is 30. Question, what is the ratio of the area of the zone of the second segment to that of the first? So our equation here, so the ratio of the zone 2 over the area of the zone 1. So this is the area of the zone 2. This is the area of the zone 1. Can you follow? Okay. So from our formula discussed, the area of the zone is 2 pi r h. So that's why I have here 2 pi r h2 then over 2 pi r h1. So 2 pi r simply cancels out and the ratio is equal to h2 over h1. So 24 over 6 is 4. So finally, the ratio is 4:1. Okay, so that is about spherical segment involving zone. So that involves zone. Okay. Next problem. The surface area of a sphere is 900 pi square centimeters. If the volume of water in the tank is 1,470.265 cubic centimeter, determine the depth of the water. Okay, so the surface area of the sphere is 900 pi square centimeters. If the volume of the tank, if the volume of the tank is 1,470.265 cubic centimeter, determine the depth of water. Bali di ay, this is a spherical tank. So this is a spherical tank and then we have water inside it. And the volume of water is 1,470.265. Determine the depth of the water. Okay. So let us say this is the spherical segment, or the spherical tank. Okay. So this is the spherical tank, and from the surface area, which is 900 pi square centimeters, I can solve for the radius. Okay. So from the surface area equal to 4 pi r squared, and that is given equal to 900 pi. So r is equal to 15. Okay. So when you have the water inside it, the volume is 1,470.265. So the water here takes the form of a spherical segment with one base. Kuha nyo? Can you observe that? Okay. So this solid here, which is the water, so the water takes the form of the solid, which is called a spherical segment with one base. So the question, find the height or the depth of water. Okay. So radius r equal to 15, and this is the requirement, the height of the water. So we have the formula for the volume of this spherical segment, pi h squared over 3. Then times 3r minus h. So the volume is equal to 1,470.265 equal to pi h squared over 3 times 3 times r minus h. The only unknown here is h. So 6 cm. Meron pa about spherical segment with one base. Okay, we have here. A mixture compound from equal parts of two liquids, one white and the other is black, was placed in a hemispherical bowl. The total depth of the two liquids is 6 inches. After standing for a short time, the mixture separated, the white liquid settling below the black. If the thickness of the segment of the black liquid is 2 inches, find the radius of the bowl in inches. Okay? So, how will you solve that? What is your approach? Figure muna, no? Okay. So, bali, originally, there is a mixture of two equal parts of two liquids. They have colored, they have colors, one white and the other is black. So, at first, they mix, huh? Then they are placed in a hemispherical bowl. Now, the total depth is 6 inches. I-take note natin yung mga values, ha? So, after standing for a short time, the mixture separated, the white settling below the black. So, when the liquid settle, nag-separate sila, the white is below the black. So, the thickness of the black liquid is 2 inches. Find the radius of the bowl. Okay. So, we can draw it na. So, kung i-draw natin, ito yung figure natin, ha? Okay. So, this is now the figure of the bowl when you have the two liquids separated already. So, the total depth of the two liquids is 6 inches. Now, when they settle, white settle below the black with a depth of 4 inches. The black liquid has a depth of 2 inches, but they are of the same volume. So, question, what is the radius of the bowl? Okay, so how will we form our equation? So, take note that the volume of the white liquid is equal to the volume of the black liquid. And then, if they are of equal volume, so the total volume there is twice of either the white or the black. Twice of the white liquid or twice of the black liquid because they are of the same volume, equal parts of the two liquids. Okay. So, notice that the volume of white is a spherical segment with one base. So, I will use it for our relation. So, the total volume is equal to twice the volume of the white. Okay. So, this takes the form of a spherical segment. So, pi 6 squared over 3 times 3r minus 6. So, this is the total volume. Where r is unknown and then h is 6. Equal to twice of the white liquid, which is pi 4 squared over 3 times 3r minus 4. So notice h here is equal to 4. So have you noticed that pi over 3 cancels out and we are left with this equation. We divide by 4, so we have this. And then solving for r, this is equal to 7.33. Okay? So that is spherical segment with one base. So the second we have here is spherical segment with two bases. Okay. So this is a part of a sphere bounded by two parallel small circles. So may dalawa na tayong small circles called the bases. Yung kanina isa lang. Then the perpendicular distance between the bases is called the altitude of the segment. Okay. So we have the figure, by the way, sometimes spherical segments are called frustum of a sphere. So possible you may encounter problem. The name is not spherical segment, but that is termed as frustum of a sphere. Okay. Okay. So this is the spherical segment with two bases. So we have now the two bases, in which they are small circles. It can be somewhere here also, if the two bases are cut from different parts, from the different sides from the center of the sphere. Ito, the same side, So we have base 1, base 2. So I will call the radius is r. So radius of the first base r1, radius of the second base r2, and then we have the height h. So the formulas, we have here volume equal to pi h over 6 times the quantity 3 times r1 square plus r2 square plus h squared. Then, area of the zone. By the way, the solid is also, hindi ko na nalagay dito, the solid is called the segment. The surface is also called the zone. Now, for the zone, we have the same formula, 2 pi rh, where r, take note, r is the radius of the sphere. But here, r1 and r2 are the radii of the bases. So, small base, bigger base. Okay, so representative problem. I think may isa. Okay, so we have here. A sphere has a diameter of 32 mm. A frustum of a sphere is created by passing two parallel planes, one 12 mm from the center and the other 10 mm from the center, and on opposite side of it. Okay, so kuha niya. Compute the volume of the frustum. So, there is a sphere with diameter 32. So, radius is 16. Okay. So, the frustum is created by passing two parallel planes. Similar to this, no? One, 12 centimeters from the center. The other, 10 centimeters from the center. But, from opposite side of it. Meaning, from opposite side from the center. From the center of the sphere. Okay? So, siguro kuha na natin, no? Ma-visualize na natin. I-draw natin, ha? Okay, so this is our spherical segment with two bases. If this is the center of the sphere, so this is cut 12 centimeters from the center. This is 12 centimeters from the center or 10 centimeters from the center on the other or both on opposite side from the center of the sphere. Okay, so what are the values given? Radius is 16, so radius is equal to 16. Then R1 unknown, R2 unknown. But you have here 12. Okay, you have here 10. So have you noticed that we can solve for R1 using this triangle? No? So this is 12, this is unknown R1, the radius here is 16. So from the triangle, R1 squared equal to 16 square minus 12 square. So R is 10.583. Also, we can solve for R2. In the same way, this is 10, this is R2 unknown, this is also 16. So, by Pythagorean, R2 squared is equal to 16 square minus 10 square. And R2 is 12.49. Okay? So, after that, we have R1 and R2. The question here is the volume of the sphere, no? Okay. So, this is the height, the altitude of the segment. Because we have the perpendicular distance between base 1 and base 2. So, 12 plus 10 is 22. So, we can substitute to the formula for the volume of the spherical segment. Or in the problem, as you notice, this is termed as frustum of the sphere na. Okay. So, pi h over 6 times this. So, h is 22. R1, 12.40. 10.583. R2 is 12.49. So, substituting values, we have 1483.6.69 cubic centimeter for the volume of the frustum. Okay, so, ano pa ba? So, if we recall, sphere, and then we have wedge. Wedge, and then we have spherical segment with one base, and then we have spherical segment with two bases. Okay, anong sunod? We have here a prismatoid. Okay. So, what is a prismatoid? So, prismatoid is a solid whose bases are two parallel polygons or any geometric figure. And four lateral faces are triangles, trapezoids, or parallelograms, with one side lying in one base and the opposite vertex or sides lying in the other base of the polyhedron. Okay, so para maano natin kasi hindi madali kung reading lang, no? Walang makikita. Okay, so this is a prismatoid. So this is composed of two parallel bases. So base 1, base 2. So the bases are not of the same or are not of the same figure. So as you notice here, the upper base is triangle, the lower base is a rectangle. And then the other faces, which are called the lateral faces, it can be face of a triangle, trapezoid, parallelogram, or rectangles. So, yun. Okay? Makita niya? So, I will call the upper base area 1. The lower base area 2, and the perpendicular distance between the bases is the altitude h. Okay. So, for the computation of the volume of the prismatoid, we need the area of the middle section. So, we call it A sub m. So, if this is h, this is at h over 2, h over 2. So, area of the midsection. So, how will we solve for the volume? So, the formula is this. So, h over 6, then times area 1 plus 4 times area of the midsection plus area 2. H, area 1, area 2, A sub m, area of the midsection. Okay, so if in case, we have a solid in which it meets this situation. So if you are asked for the volume, then simply we can use this formula. Okay. So, siguro I can have two representative problems for this. Okay. Problem 1. A solid has a circular base. Base, base na lang. Base. Lagyan rin ng E. Dalawa na. A solid has a circular base of 5 centimeters. Find the volume of the solid if every plane section of it perpendicular to a certain diameter of the base is a square. Ano daw? A solid has a circular base. Picture out, no? A circular base of 5 centimeters. Base of 5 centimeter radius, na? A solid has a circular base of 5 centimeter radius. Just add na lang, ha? So, take note. Circular base of radius 5 centimeters. Find the volume of the solid if every plane section of it perpendicular to a certain diameter of the base is a square. Okay. So, we have that here, na? So, ito yung figure. So, I have here a circular base. Then, if we consider this fixed diameter, the diameter of the base, now every plane section cut, when you cut the solid, every plane section here forms a square. So, this is one square. I will illustrate another square cut. So, we have another square there. We have another square. We have another square. I hope makikita niya. So, this is what we call the base, which is a circle of radius 5 cm. So, the distance end to end, so that is 10. Okay. So, can you picture out the solid? So, ito yan, Okay. So, have you noticed that we can solve the volume of that solid by using the Prismoidal formula? Why? Because I can consider this as our end area 1. This point and the area there is equal to 0. I have also another point here in which this is the end area 2, A1, in which or A2, in which the area is also 0. And then notice, we have here squares cut. If you cut the solid, perpendicular to the fixed diameter, this is always a square. So notice that the midsection is also a square. That is the red square there. So this is at r equal to 5, r equal to 5. So meaning this is also 10. This is 10. So I can solve for the area of the middle section. So that is 10 times 10, which is equal to 100. So I can now solve for the volume of the solid. So h over 6, area 1 plus 4 times the area of the midsection plus area 2. So substituting values, all are there. H is 10. This is the 10. 0, 0, and then 100. So substituting values, that is 667 cubic centimeter. Okay? So, I will add one more, no? So, as you notice, no? As long as you can evaluate area 1, area 2, the end areas, then we have the area of the mid-section. Okay. So, problem 2. A cylindrical tank 4 meter in diameter and 6 meters high is filled with water. It is then tilted to a position enough for water surface to cut the diameter at the base. How much water is retained in the tank? Okay. So, originally, the cylindrical tank, 4 meters in diameter and 6 meters high, fully filled with water. Then, you tilt it in a position such that the remaining water there, the water surface cuts the diameter at the base, no? Or the, ano na lang siguro, we can say that the water surface coincides the diameter of the base. So, how much water is retained in the tank? Okay, so we can draw it now so that we can view it and analyze it. So this is now the tilted position of the tank, such that if this is the water surface, it cuts the base at the diameter. So below the blue lines are the water remaining. So the blue lines there, the blue part there is the water surface. So solve for the volume of the water remaining. How much water is retained in the tank? So this diameter is 4 meters. This length is 6 meters. So the height of the cylinder is 6. I think hindi ko nalagyan ng values. Okay. So have you noticed that we can use our Prismoidal formula to solve for the volume of water remaining here? How? Because I can consider this as area 1 and this is 0. This is end area 2 and that is also 0. And this is the area of the middle section. And that is the area of the middle section is a triangle. And this triangle, this is 2 and this is 6. Do you follow? So this is 2 and this is 6. Wala lang values hindi ko nalagay. Sorry, nalimutan ko. So, the area of the middle section is 1/2 2 times 6. And that is equal to 6 cubic, 6 square meters. So, I can now substitute for the values to the formula. H over 6, area 1 plus 4 times area of the midsection plus area 2. Area 1, area 2, 0, 0. This is 6. H is 4, so H is 4. Distance between end areas. So we have 16 cubic or 16 cubic meter, cm cube. And this siguro erase C, erase C because meter man yung unit, so 16 cubic meter. Okay, so that is about Prismatoid, we have here similar figures. Okay. So, as you recall, if we recall, we have similar figures in our plane geometry. We can apply also similarity in solid figures. And similarity of the solid figures follows the same. So, we will follow the same proportion as introduced in the plane figures. Okay. So, for our discussion, I will just show two similar cones. So, this is cone 1, cone 2. So, notice that they are similar. They are of the same shape, but not of the same size. So, I will call R1 for the radius of first cone, H1 the altitude of the second cone, L1 the slant height of cone 1. So we can just say that all the subscript 1 refer to the first cone. Okay? Then for the second one, we have radius R2, height H2, slant height L2. Okay? So what we can apply? So first, we have the linear ratio. So any dimension ratio, corresponding ratio of the dimensions, no, linear unit are equal. So we can have, so R1 over R2 equal to R1 over R2 equal to H1 over H2 equal to L1 over L2. And so on. C1, circumference 1 over circumference 2, as long as you have linear ratio. So the corresponding linear ratio are equal. Okay. How about the area ratio? So let's say if this is area 1 for the area of cone 1 and area 2 for the area of cone 2. Okay. So it can be surface area or base area, no? As long as any area involved in the solid. So we have the ratio of the areas, area 1 over area 2, that is equal to the square of the linear ratio. So area 1 over area 2 equal to R1 over R2 square, equal to H1 over H2 square. It is equal to L1 over L2 square, and so on. Okay. So how about if we have the volume? So volume V1, volume V2. So we have also the proportion that the ratio of the volume V1 over V2 is equal to the cube of the linear ratio. So V1 over V2 equal to R1 over R2 cube equal to H1 over H2 cube equal to L1 over L2 cube equal to C1 over C2 cube, and so on. So volume ratio is equal to the cube of the linear ratio. And then last, number 4, we have the relation between the ratio of the areas as to the ratio of the volumes. So we have here A1 over A2 cube equal to V1 over V2 square. So the ratio of the area cube is equal to the ratio of the volumes square. Okay, so we can apply, so those are the relationships that we can apply, or the equations that we can apply involving similar figures. Okay. So we have here problem 1. Two similar cylinders have pentagonal bases. The sides of the base of the bigger cylinder are 3 centimeters, 5 centimeters, 6 centimeters, 8 centimeters, and 9 centimeters long. The shortest side of the base of the smaller cylinder is 2 cm. If the total lateral area of the smallest cylinder is 144 square centimeters, what is its altitude? Okay, so we have two similar cylinders, pentagonal base. By the way, in our discussion, in our previous discussion, when you say cylinder, it is when you have a circular base, But when you say cylinder, the term cylinder is applicable to any solid with a constant cross-section and extending through a certain height or length. So that is why we have a right circular cylinder if the base is a circle. We have also elliptic cylinder. So if you say elliptic cylinder, ano ba yan? So that is a cylinder in which the base is an ellipse and extending through a certain length or height. Okay. So meaning, when you say prism, we define prism as a solid with a polygon base. But that is also a term, or we can term it also, the solid is also a cylinder, as long as we have a constant cross-section extending to a certain height. So walang problema yan. Prism and cylinder are just the same. So as you notice, when we discussed last meeting and we compare the volume computation and the surface area, lateral area, the same lang. Only we change the formula for the cylinder if we consider as a circular base. If we consider a circular base of it. Okay. So we have the solution. This is the bigger cylinder. So the bigger cylinder has a base of a pentagon with dimensions 3, 5, 6, 8, 9. Then we have a smaller, similar cylinder. The shortest, no, the side. If the shortest side of the smaller cylinder is 2 cm, then the total lateral area of the small cylinder is 144. What is its altitude? H2, no? Okay. So I will consider first the first cylinder, no? I will let P1 equal to the perimeter of the base. So P1 is equal to 3 plus 5 plus 6 plus 8 plus 9. So P1 is 31. Huh? Okay. So I have P2, the perimeter of the base of the smaller cylinder. So I cannot sum up the sides, but I will just use proportion, similarity theorem. So by similar figures, P2, the perimeter of the small cylinder, is to P1 equal to 2 over 3, ratio of the shortest side to the shortest side. So we have P2 over 21. Ay, why is it that we have 21? 31. Kindly check, ha? So 2/3 times 21. 31. So this is 31. So this is 20.67. Kindly check. This is correct na, 31. Kindly check. This is not 21. This is 31. Apat na. Misprinted, no? P2 over 31 equal to 2/3. Okay? So I can solve for P2. That is 20.67. Correct. If you change this to 31, then times 2/3, that is 20.67. Okay. Then here we have the lateral area of the smaller equal to perimeter of the base times the height. So the lateral area is 144, perimeter is 20.67. We can solve for H2. Height H2 pang 5 na, walang subscript na to. Pakilagay na lang, ha. Sorry, tao lang. So 6.97. Okay. Yeah, next we have here. May problem pa man siguro? Okay. The diameters of two spherical bearings are in the ratio 2:5. Okay? So the diameters of two spherical bearings are in the ratio 2:5. What is the ratio of their volumes? Okay, what is the ratio of their volumes? So this is the diameter D1 of the first, then diameter D2 of the second. So D1 over D2 is 2 over 5. No? So the ratio of the diameters, D1 over D2 is 2:5. What is the ratio of the volumes? Very simple, no? V1 over V2 is equal to D1 over D2 cube. Volume ratio is equal to the cube of the linear or dimension ratio. Madali yan. 2 cube 0.064. Okay na? Kuha na? Okay. We have here. A car has a mass of 1,000 kilograms. A model of a car is made to scale 1:50. Determine the mass of the model if the car and its model are made of the same material. Okay? So, a car has a mass of 1,000 kilograms. Actual car, na? Then, we have the model. A model of a car is made to scale 1:50. So, determine the mass of the model if the car and its model are made of the same material. Okay. So, we have here, na? So, notice that mass is equal to volume times density, na? Mass is equal to volume times density. Density is kilogram per, say, cubic meter, na? Kilogram per cubic meter, and volume is in cubic meter. Cancel out yung cubic meter, so mass na lang, ha? Okay. So, if we solve for the volume is equal to mass over density. Right now? Okay, now. We cannot have the relationship for mass at first. No, we cannot have the relationship for the mass of the actual and the model. But what we can have is the relationship of the volume of the actual to the volume of the model. But we are not given those values. No? We are given the mass. So, volume of model over volume of car is equal to the cube of the scale. Huh? Scale is 1 is to 50. And again, when you say scale, this is model is to actual. So 1 unit in the model corresponding to 50 units in the actual. Then we cube it because we have the volume ratio. Okay. But we can substitute volume of model equal to mass over density of model. Volume of car can be replaced by mass over density of volume of car. So we can have that here. But notice, the car and the model are made of the same material. So the density will simply cancel out because they are equal, or they have the same density, same material. So what is left in the numerator here is mass of the model over the mass of the car. So meaning, the volume ratio is just the same as the mass ratio, equal to the cube of the proportion. Because mass is a function of the volume. So instead of mass, we have the same density, we can just use the volume. Okay, so we have now mass of model over mass of car equal to this. So the answer is this. So mass of car is 1,000, so multiply 0.008 kilograms, or express that in grams. So we have 8 grams. Okay, so that is similar solids.